Alright, this is Intermediate Lesson 9, Measurement, which basically is going to deal with the perimeter and areas of different shapes, like triangles, rectangles, circles, and composite shapes, which means combining those into bigger shapes. So let's first go over different things about a triangle. In a triangle, each side is called a base. And then, if you recall from geometry, an altitude is the segment in the triangle that goes from a vertex to the opposite side, forming a perpendicular. So in this case, H is a base. You could also draw a base. Pardon me. H is an altitude. You could also draw an altitude from this base, making a perpendicular. You could draw an altitude from this base, making a perpendicular. So when you find the area of a triangle, it's 1/2 the base times the height. Height is an altitude. So you could find the area by taking the length of this base times this height, or you could find the area by taking this base and this height, or you can find the area by taking this base and this height. The important thing is that you know that the base and the height means altitude, that they are perpendicular to each other. It has to be the case. So to find the area of a triangle, you take 1/2 times the base times the height. To find the perimeter, you add up the lengths of all the sides. It's true in any shape. Let's look at an example. What is the area of this triangle? Well, this is pretty simple. We have the base of 5. We have this perpendicular altitude to that of 4. So the area of this triangle is 1/2 base times the height. It's 1/2 of 5 times 4. Just a friendly reminder, when you're multiplying 3 or more numbers, you can multiply in any order that you want. I'm going to multiply 1/2 times a 4 first and get 2, and then 2 times 5 is 10. So the area of that figure is 10 square units. We don't know what units they are. It could be inches, could be feet, could be sheep herders. We don't know. Another example. A parking lot shaped like the triangle in the figure below is completely fenced in during a street fair. If x equals 25 feet, what is the total length in feet of the fence? So it's asking for perimeter. The perimeter is 2x plus 4x plus 5x, which is 11x. And then you're told that x is 25. So that means that the perimeter is going to be 275 feet. Boom. Number 3. In the figure below, segment AB is congruent to segment BC. When you're given information about the picture that's not in the picture, you need to put it in there. So to show that those are congruent, we're going to put the same number of dashes on those. Now, if you recall, this isn't relevant to this problem, but you wouldn't know that at this point. The isosceles triangle theorem that we learned in a previous lesson says if those are the same, then these base angles are the same. Sometimes that's extremely helpful. I'm just going to throw it in. Segment AC is 6. So this whole thing here is 6. Segment BD is 4. What is the perimeter of triangle ABC? Well, this is going to require some knowledge from isosceles triangles. In an isosceles triangle, which this big triangle is, anytime you have an altitude from the vertex angle, you know it's an altitude because it forms a 90-degree angle. That's also going to be an angle bisector. Cut this in half. It's also going to be a median, which means it cuts this side in half. Now, those are things that you should know and commit to memory. So what that means is this triangle that we see right here, just going to redraw it. 4. If this whole bottom side is 6, then that means each half of those have to be 3. So this is 3 here and 3 here. Well, without doing much work, this is a 3, 4, 5 right triangle. Pythagorean triple. If you don't remember that, use the Pythagorean theorem, and you would take 3 squared, which is 9, plus 4 squared, which is 16. Add those, you get 25. That means that the hypotenuse has to be the square root of 25, which is 5. So if we know that's 5, these two triangles are the same, that green triangle and this blue triangle. This is also 5. That's for the perimeter of ABC. So the perimeter of triangle ABC is 5 plus 5 plus 6, which of course is 16. Boom. Perimeter and areas of rectangles. First of all, what is a rectangle? It's a parallelogram, which means the opposite sides are parallel. If it's a parallelogram, that implies it's a quadrilateral. It means there are 4 sides. If it's a quadrilateral, that implies it's a polygon. Polygon is made up of segments. Each segment intersects another segment at its endpoint. A rectangle is special parallelogram because it has 90-degree angles. Some other facts about rectangles is opposite sides have to be the same length. To find the area of a rectangle, you just take base times height. Base is any side, height is perpendicular to it. Find the perimeter of a rectangle. Just like any shape, you add up the lengths of all the sides. So we're going to have B and a B and an H and an H, which means we got 2 B's and 2 H's. Area and perimeter. Question 1, what is the perimeter of this figure? Well, it's a rectangle, so opposite sides are the same. If that's 5, this is 5. This side's 3, this is 3. So the perimeter is going to be 5 and 5, which is 10, 3 and 3, which is 6, 10 and 6 is 16. Number 3, if the diagonal of a square is 5 square roots of 2, what is the area of the square? This question is deep. Let's first draw the square. A square is a rectangle in which all sides are the same length. So we're supposed to draw a diagonal. It says the diagonal of the square, just like this, is 5 square roots of 2. What is the area of the square? To find the area, we have to know the length of the base and the height. Since it's a square, the base and the height are going to be the same value. So if you know anything about special right triangles, which we haven't talked about yet, you would know that each of these are 5. So the area is 5 times 5, which is 25. So let me explain the special right triangles. And this is extremely important that you write this down and that you memorize it. In every 45, 45, 90 right triangle, whatever the length is, opposite the 45s have to be the same. We're just going to call that alpha. Whatever's opposite 90 is whatever's opposite 45 times the square root of 2. This is true in every 45, 45, 90 right triangle. So how does that relate to this problem? Well, if the diagonal is 5 square roots of 2, in our special right triangle with alpha square roots of 2, that means that 5 has to be alpha, which then means that these two sides are also alpha. How do we know this is a 45, 45, 90? Well, once again, there's lots of facts about geometry that one would need to know for the ACT. If the angles are 90 degrees in this square, this diagonal will always cut that in half, which makes each of those 45. That's true in any rhombus. A rhombus means it has 4 sides and all sides are the same length. Alright, let's move on here. I'll tell you what, let me tell you another way to do this problem. Let's say you don't remember special right triangles. And let's just backtrack a little bit. So we have this picture, we get 5 square roots of 2. We don't know what these are, we know they're the same. You could use the Pythagorean theorem to figure out what those are. X squared plus x squared equals 5 square roots of 2 squared. X squared plus x squared is 2x squared. 5 squared versus 2 squared, you square the 5 and you square the square root of 2, you're going to get 25 times 2. If you divide both sides by 2, you get x squared is 25. Therefore, x is going to be a positive 5. And then from there you find the area as base times height. All right, number 4. A painter is hired to paint a room that has 2 rectangular walls that measures 8 feet by 12 feet. A third rectangular wall measures 8 by 10, and a fourth measuring 8 by 4. There's no windows, and the door will be painted too. How convenient. If the painter charges $1.50 per square foot, how much will the job cost? So there's 2 parts to this problem. We need to find the total area, and then we need to find the total cost. To find the total area, we need to find the area of each room. There's 2 rectangular, the area of each wall, just one room. 2 of the walls are 8 by 12. So the area of, let's say, wall 1 is going to be 8 times 12. The area of wall 2 is also 8 times 12. Then it says the third wall is 8 by 10. So the area of wall 3 is 8 by 10. The final wall is 8 by 4. It's a weird room. So to find the total area, we're going to add all those together. 8 times 12 is 96, 8 times 12 is 96, 8 times 10 is 80, 8 times 4 is 32. If you add those together to get the total area of total, you're going to get 304 square feet. Doesn't answer the question. Notice that's one of the answers. If the problem is multiple steps, I like to put one of the intermediate steps as an answer. ACT is a horrible thing for jerks. The jerk squad made it. The painter charges $1.50 per square foot. So the cost is going to be the dollars per square foot times how many square feet. That's going to end up being $456. Dunsies. Number 5. In the figure below, the rectangle ABCD has an area of 15. What is the length of the diagonal? This is also a 2-part question. To figure out the length of the diagonal, you got to first find the length of BC. We'll call that X. Once we find that, then we're going to find the length of AC. We'll call that R. Actually, let's call this BCY. So, area of a rectangle, base times height. Base, we'll say, is 6. Our height, we don't know. We do know our area. It's 15. If you divide both sides by 6, you're going to get that y is 3.5. Scratch that. 2.5. Notice, actually don't notice. All right, so we know that y is 2.5. We're supposed to find the length of the diagonal. Since this is a rectangle, this is actually a right triangle. Find the hypotenuse, where you take a side squared, well, a leg squared, plus another leg squared, that equals the hypotenuse squared. 6 squared is 36. 2.5 squared is 6.25. If you add those together, you get 42.25. And if you square root that, going to get 6.5. I'm just checking in a calculator. That's right. Yep. Now, as far as the answers go on this paper, we know that F couldn't be the answer and that G couldn't be the answer right away. And the reason we know that is because the hypotenuse is the longest side of the triangle. And since one side is 6, the answer has to be bigger than that. So if you were just guessing for this problem, you would at least know that you have 1 out of 3 choices. Alright, let's moving on. Circumference and areas of circles. A circle is a collection of points the same distance away from a given point. That given point is the center. The distance from the center to the circle is known as r. To find the area of a circle, you take pi times r squared. To find the circumference of a circle, which means the same thing as perimeter. Circle's too special to use that word. Precious little circle. It's 2 times pi times r, which is the same thing as pi times the diameter. Because 2 times r, twice the radius, is the diameter. Let's look at an example. What is the circumference of a circle with a radius of 5 over 2? The circumference is 2 pi times r. R is 5 over 2. We are multiplying and dividing by 2 here, so they cancel. So I end up with 5 pi. Circumference, 5 pi. Number 2, Polly, the cracker, has a round hot tub with a diameter of 6 feet and a depth of 5. I'm going to draw that. She has a round hot tub. The diameter is 6 feet. I like to use the radius instead of the diameter. And the depth is 5, which would be the height in this picture. She wants to purchase a circular tarp large enough to cover the top of the hot tub with no more than additional 6 inches overlap on the sides. Which of the following available round tarp sizes of the following, which one should she buy? So it turns out this 5 foot is irrelevant. She wants to put a tarp on the top, and she's cool if this tarp sticks over an additional 6 inches. 6 inches, as far as feet goes, is half a foot. So even though this top of this pole is 3 feet, she's cool with this radius being 3.5 feet. So, to find the area of that circle, it's pi r squared. So if we put 3.5 in for r, put that into our calculator, 3.5 squared times pi, we end up with about 38. Now looking at my answers, it says that she's fine with no more than an additional 6 inches of overlap, which means this represents the largest possible that she would want. That's more than that, that's more than that. So the closest thing to this is going to be 36 square feet. So that's going to be our answer. Another way to look at this problem may be a little less complicated. If we just take the original size of the circle, it's pi times 3 squared, which is 9 pi. 9 times pi is 28.27. So that means that's the smallest she would want it, which eliminates those. So really, there's only one choice no matter how you look at the problem. Alright, so using these formulas, use geometric formulas, the formulas that we just learned for circles, rectangles, and triangles, thrown into these problems. The formula for calculating the area of the triangle is 1/2 the base times the height. B is the base, h is the height. If the triangle has a base of 10 and a height of 8, what is the area? Well, that's ridiculously easy. It says base is 10, height is 8, half of 10 is 5, 5 times 8 is 40. Done. Number 2, the formula to find the area of a rhombus, is d1 times d sub 2, where those are the diagonals, divided by 2. If the rhombus has a diagonal of length in 4 and 6, what's the area? So area 4 times 6 divided by 2, it's 24, divided by 2, it's 12. Done. If you're trying to find the perimeter of a composite shape like the one that you see here, it is as simple as finding the perimeter of a rectangle. Now let me explain. If you take the top length, the total length, which is 6 and 6, that represents the total length of the top of this rectangle. So if the top is 12, the bottom is also 12. If you take the height or width of the rectangle, depending on your perspective, it's 7, because you got 3 and 4 make up the left side. That means that the right side has to also make up a total length of 7. So the perimeter is simply 12 plus 12, which is 24, plus 7 plus 7, which is 14, makes the perimeter 38. Hope that makes sense. 2, in the figure below, triangle ABC is a square, and CDE is a right triangle. If segment BC is 12, as soon as you read that, put it into the picture. I'm going to do more than that. Since it's a square, that means these are all 12, which now means we know the length of one of the sides of the triangle. DE is 16. What is the perimeter of the combined figure? Let me trace over this. What's the perimeter of the combined figure A, B, C, E, D, and you go back to the beginning, A. So we know most of these. We got 12 and 12 and 12 and 16. We do not count this 12 because it's not part of that perimeter that it's asking for. So if we just add those together, let's just do that real quick. That's going to be 36 plus 16, that's 52. So right now we're at 52, which means those cannot be the answer. If you just wanted to estimate, what could the length of this side over here be? It's going to be bigger than 16, and it's going to be bigger than 12. It's not going to be that much bigger. What did we say that was? 52, I think. So right now we're at 52. So we need to find this other side. This other side's not going to be 100. That eliminates that. We're going to have two choices. 72 or 77. This triangle, you can find the length of this side in a couple ways. You can use the Pythagorean theorem, it works wonderfully, or if you recognize this is a special right triangle. This is based upon the 3, 4, 5. If you multiply each of these by 4, and you're going to find the length of this other side, makes that 20. So that means this is 72. to sum up, we knew that each of these sides were 12. We were told this was 16. To find this is 20, use either the Pythagorean theorem or special right triangles. Add up all those numbers, you get 72. All right, in the figure below, triangle BCDE is a square, has an area of 4. Well, if the area of this is 4, that means each of these sides has to be 2, because 2 times 2 is 4. What is the perimeter of triangle ABE? That's this triangle here. If this is a square, all these sides are 2. Since each of these angles are 60, it makes this an equilateral triangle, which means all the sides are the same length. It was in a separate lesson that we talked about equilateral triangles. If all the angles are the same, all the sides have to be the same. So the perimeter of the triangle is 2 plus 2 plus 2, which is 6. All right, that is the conclusion of set 9. Happy time here. Please do exercise in set 9. Take your time, don't rush through it, don't give up right away. Do your best.